9, triangles, vocab, 6 terms. And again, none of these terms should be too difficult, but what we're going to end up doing, and you'll do this on your quiz and test, is you're going to classify triangles in two different ways. You need to classify them by their sides, which is their own 3 little ways of describing them, but they're also classified by angles. So when you're classifying triangles on your quiz, I will say classify by both angles and sides. So it'll be just one answer, but you'll have to, classify both ways. And that's pretty standard here. So again, we've covered this last year here, but to classify by angles, and we talked again yesterday that triangles and quadrilaterals have some deeper classifications to them. So today we're going to explore the triangles and their classifications. So there are 3 of them. Again, you probably already know them here, but an acute triangle, right, has 3 acute angles in it. And again, I can briefly sketch one here, but certainly an equilateral triangle would be an acute triangle. Equilateral is classifying by sides, and we'll cover that in a minute here, but if all 3 of the angles are less than 90 degrees, which is very possible with a triangle, 60, 60, 60, all 3 of those are less than, all 3 of those are acute, then it's an acute triangle. All right? A right triangle. And a right triangle has 1 right angle in it. Right, and again, when you're seeing, a 90-degree angle, obviously the other 2 angles would be acute, but right triangles are defined by having that right angle. Right triangles are a big deal. In geometry, you'll spend endless time working with right triangles as you continue your math career. So, but again, always defined by that little square there. Right, we've talked about the box before. So if you see the box, you're looking at a right triangle. An obtuse triangle has 1 obtuse angle in it. Okay, 1. So maybe something like that, I guess you could say. Obtuse angles bigger than 90, less than 180. Be impossible to have 2 obtuse angles in a triangle because sum total is 180, and you can't have 2 angles that are bigger than 90 degrees. How would that work? So that's it. If they're all 3 acute, you're looking at an acute triangle. If it's got a right angle, that's a right triangle. If you see an obtuse angle, then it's an obtuse triangle. Got it? So that's classifying by angles. All right, classifying by sides. And again, you'll have to classify both ways in the homework and quiz. I'll say classify this by its angles and sides. So classifying by sides. And again, last year we covered all these terms, and I think you know some of them, but equilateral. So when you're classifying by sides, the angles have nothing to do with it. Just like when we classify by angles, the side measurements have nothing to do. There's a connection between those 2. I'm not going to go through it right now, but equilateral, all sides are congruent. All 3 sides are the same. And again, that would be, you'll know that to be true. You're going to have to look at the tick marks here to make these determinations when you're going through your homework or quiz. When you're classifying by sides, it's all about what's going on with these types of things here. So it's all about the tick marks. If I see 3 tick marks that are all the same, all 3, that's telling me all 3 sides are congruent. Therefore, equilateral it shall be. Number 2, the isosceles. And isosceles, 2 of the 3 sides are congruent. So again, when you see it here, you will see 2 of those tick marks. The third side is showing me is not congruent to these other two. It's a different measurement, but in this one that I drew here, as I would understand it, the left and the right side are the exact same measurement. Two of the three sides are the same. And isosceles. And finally, the scalene. None of the sides are the same. No congruency. I'll just say no congruent sides. So, this, that, and that, I don't know. But generally, you'll just see no tick marks at all. The book kind of does number 1 here. For whatever reason, they threw these tick marks. They're all different amount of ticks here, as you see. So therefore, it's showing none of them. This is not normally how you would represent this scenario at all. So I don't even know why they did it. You don't use ticks unless there's actually something, a matching tick to make somewhere. So generally speaking, a scalene triangle will just have no ticks whatsoever on it. But that's what you're looking for to classify by side. It's all about these ticks here. When you're classifying by angles, again, a right angle will be specified. If you look at number 1, you could be like, oh, that could be a right angle right there. I mean, it does kind of look like one, but unless it's specifically denoted as a right angle, don't assume, that could be a right triangle. That looks like a 90-degree angle to me. If it's not explicitly given to you, it's not a right triangle. So if I say number 3, I'll just look at number 1 here, and again, looking for 2 answers here. If I classify it by its angles and sides, what type of triangle is number 3?
Isosceles, and then it's acute.
Acute, right. So normally you say the angle first, but if I would say this with words, I would describe this as an acute isosceles triangle. But I don't really care the order you write the words. If I see acute and I see isosceles in there, then we're good here. Whatever order you write them, however you spell isosceles, this is an English class, so don't worry about that.
I think I spelled it different ways every time.
Yeah, it's that C in there in the middle.
There's a C in there?
There is, in the middle of it, so, right, so. Anyway, don't worry about that either, not a big deal here, but what do you want me to tell you here? These aren't too hard. I think you'll be able to classify both of these by their angles and sides without too much issue, so. If for whatever reason it's difficult, remember at the test sometime next week I'll start passing out note cards for you. You'll be able to build a note card for this test again, so. That's all I got here. Okay, next part here says 2 of the 3 angles are given. Find the measure of the remaining angle, then classify by its angles. So number 7, or let's just go to number 9 here. I suppose. Yeah, switch over to notes here. Yep. Okay, there's our vocab for today. And again, I got to introduce to you the triangle inequality theorem, so.
I think we're at Kleenex. Can I go see if somebody has another box? Or do we have another box?
What?
Do you have another box of Kleenex?
Yeah, I do. There should be, is in the bottom left there, just open it up. There should be a box down there. If not, I got a whole case up there. But pretty sure I got more boxes down there. Underneath the phone there, the big cabinet, that one. Yeah, there they are. Pick out your favorite kind. There you go. Okay, number 9. So what they're doing here is number 9 says 56 degrees, 19 degrees, and they want 2 things from us here. 1, they want to know what that third angle that I'm missing to form a triangle is. We know triangles have a total sum of 180 degrees, the sum of the 3, so all I would really want to do is just take 180, subtract 56, subtract 19, I come up with 105.
Yeah.
So that's what I'm missing there. And then go back to our classification of triangles by angles. What type of triangle is this? It's an obtuse triangle because obtuse are defined by having one obtuse angle in them.
Yes.
So I would want to know the missing measurement and then classify by angles. Number 11, 90 degrees, 45 degrees, What am I missing for the third degree, and what type of triangle is this here? Missing 45, that's the missing measurement, and what type of, not obtuse.
Cute.
That's by sides, we're just classifying by angle only here.
Cute.
Wait, no, right.
It's a right
Yeah,
triangle.
there's 90 degrees.
If you have a 90-degree angle, it's a right triangle. Right?
Oh, yeah.
Right, yeah, 90 degrees,
Right.
that's the thing.
Right.
Right, so. I don't know what else to tell you about that. So, next part here. So, last part, more or less here. This takes a little get. It's not hard, but the triangle inequality theorem. And we're going to need it for these last parts here. Okay. So, what we're seeing here on this part here is we have three different measurements here. Question is, could these three measurements make a triangle? If I just took a 3 centimeter piece, a 5 centimeter piece, and an 11 centimeter line segment, could I make a triangle? Doesn't matter what the triangle looks like. Could I make a triangle? Yes or no? So to figure this out here, couple things we need to know here. So we're talking about the third side usually. We're going to come back to this in a second here, but the third side needs to be less than the sum of the other sides and greater than the difference of the other sides. Right now, that probably doesn't mean a whole lot to you right now here. That's okay. So, I guess I'm going to just get my ruler out for a second. You don't necessarily need your ruler. You can just kind of roughly sketch, but I want to be precise here for you. I'm going to just start with number 13. It already tells us the answer is no, but how do we know? So 13 says 2 meters, 6 meters, and 9 meters. So what I'm telling you is pretend I just have, I'm just going to call them, trying to draw them all out here. Let's just do this. I'm going to draw a 9-inch line here. Can't even get 9 inches that way, to be honest with you.
Cut 'em off half.
Where's my
4 by 5
centimeter
and then
thing
be
here?
3 and
All
then
right. Well,
You just don't get your centimeters.
I'll draw out a different one here. Yeah, centimeters would be so micro here. So here's the deal. If I drew this 9-inch line out here, right, and then I tried to draw a 2-inch and a 6-inch line, I would never be able to connect them. So to figure this out here, you take the two smallest sides, and in this case here, that would be your 2 meter and your 6 meter, right? Take your two smallest sides, 2 and 6, add them. So 2 plus 6 equals 8. Okay? If your sum, that was that right there, the answer to my addition problem, is less than the largest side, you cannot make a triangle. I'll create a different example here in a second. So when you see these three measurements, what you're going to want to do is you're going to want to find the two that are the smallest, all right? Whatever it would be. Number 14, 3, and 5. I'll add them up. 4 and 7, I'll add them up. 8 and 10, I'll add them up. When you add up those two numbers, if you get an answer, when you add it up, that's less than this, you cannot make a triangle. This one's going to be no, I can't make a triangle. So I'm going to just use a different one. I'm going to say one that I can do. I'm going to say 1 inch, 2 inch, and 4 inch. Okay? So I'm gonna draw a 4-inch line here, okay? 4 inches, agree with that?
Yes.
Okay, now I'm gonna try and make a triangle with these two pieces. So I'm gonna draw a little 1-inch piece here. I'll go really, really narrow. Okay, so would you say that's a 1-inch line segment there? Is that fair? Now I'm gonna draw my 2-inch line segment.
Might be possible.
There's my 2-inch, and you can see
No, never mind.
I can't, remember, a polygon is defined by all the line segments meet at endpoints. We talked about this yesterday. This, with this open gap here, means it's not a polygon, and if it's not a polygon, it's not a triangle. Triangles are polygons. So there's simply no way you can do it. If that's the side's too long, no matter how small I make it, my 3 inches here is never gonna get to this 4-inch line. It's just, how's it gonna happen, right?
It won't.
It won't. So that's all you're trying to do here. All you need to do is measure these two numbers up. If I say number 15, I got a 4-foot piece, a 7-foot piece, and an 8-foot piece. Will that make a triangle, yes or no?
Yes,
Yeah, how do you know?
because it adds up to 11.
Right, because when I add 4 plus 7, that equals 11. 11 is, again, if it gets, yes, yes, yes. And again, I'll just do another one here. I'll just say 2 inches, 3 inches, and 4 inches this time. So once again, draw my little 4-inch piece here. Boom. Okay. Now I got a 2-inch piece here, so I'll just kind of 2-inch here again. And then I'll have a 3-inch piece, and again, my 2-inch should probably go higher up, but you can see clearly, I mean, this would have to go higher up to make it perfectly perfect, right? But clearly I can make a triangle. With those 3 pieces there's no issue here. So because 2 plus 3 is 5, 5 is greater than 4, yes, I can make a triangle, yes. So all you're really answering here is, does it make a triangle, yes or no? Add up the 2 smallest sides. If you get an answer that's bigger than your third side, you got it. If you get an answer that's smaller, not so much. You guys try number 17 and 19. Do those two make triangles, yes or no? 17, 5.3, 9.3, 15.2. And number 19, 9.6, 10.2, 20.3. And all I really need is a yes or no answer to these here, but all right, number 17, what do you guys think? Can I make a triangle?
No.
No, because this plus this is 14.6. Nope, never gonna work. I'm never gonna even reach that one, so I cannot. 19,
Yes.
nope.
No.
These add up to 19.8. Again, also less
I got it
than.
backwards. Whoopsie
Yeah.
daisies.
First
Whoopsie daisies, I did
In
it
this
backwards.
case, both of them are no. No and no. It happened to be here, so. All right, good with that? Great. Last part here. So, I'll just make so there's not a lot of problems. So I'm going to say what we got going on here is they're giving us a measure of 2 of the 3 sides of a triangle, okay? We don't know what the third side is. So I'm just going to make up something. I'm going to say the measurement of, I'll just do what they do, AB, I'll just say 5 inches. And then I'll say the measurement of AC is 8 inches. So my question to you would be, what about BC? Okay. And there's 2 different things going on here. So to solve this, again, now we're gonna kind of go back to our theorem here, where I'm looking for two answers, I guess, and you can represent this a couple different ways. Because I don't know if BC is the longest side, or I don't know if it's the shortest side. It could be either one. We don't really know. I just got a 5-inch piece and an 8-inch piece. So how do I solve it? Two things here. To find out what BC is, and you can do this in two different, whatever way you want. But I need to, remember, two answers. So first, subtract the two sides to find if BC is the small side. So all I would do is go up here. In this case, I'm assuming this is the biggest side, this is the middle side, and BC is the tiny side. So I take the biggest side I got, which would be 8, subtract the smallest, that side 5, meaning BC could be 3 inches long, because 3 plus 5 is 8, and again, it has to be greater than, but don't get too wrapped up in this here. But 3 plus 5 is 8. This third side, BC, could be 3 inches long, as small as. All right, this is the smallest it possibly could be. Okay, so that's one of my answers here. Now, I also need to add the two sides together. In this case, if BC is the long side, if it's the long side. So now back I go here, 8 plus 5 is 13 inches. BC could also be 13 inches long, or anywhere in between those two. What they want here is the range.
Oh, so you just like subtract those, right?
I need to know the smallest it could possibly be and the largest it could possibly be. So what I would want for an answer here, and you could represent this a couple ways, but I could say it could be 3 is less than BC is that, or if you want to write it a little easier, you could say between 3 and 13 inches is fine. Greater than 3 and less than 13. I don't need all of these references here, but somehow, some way, I need to know, because again, I don't know if BC is the longest side, the shortest side, or somewhere in the middle. But whatever it is, it has to be at least 3 inches long, because 3 plus 5 is 8. That makes a triangle. But if it's the longest side, 5 plus 8 is 13. So whatever it is, it's somewhere between 3 and 13 inches. So again, all I need to do is subtract the two values. Boom, that tells me if BC was the smallest side, what it would be. I need to add the values together. That tells me, boom, what BC is if it's the longest side. And again, it could be the middle side, but whatever it is, it's somewhere between 3 and 13 inches long. Takes a little getting used to, but if you just think about it, it's just subtract the two numbers, add the two numbers, and however you want to reference. I mean, this might just be the easiest. If you're not clear on that, just say between your small and your big number, right? So here, I'll give you a 2 to try here. So I'll just say, I'm not even going to measure it. I'll just say if one is 4.2 inches and one is 6.3 inches, what's the range of the third side? And if one is 5 1/3 and the other is 2 1/2, what's the range?
Oh, why? Why?
Add, subtract with fractions. Hint, common denominator necessary.
Why?
Why did you do that?
You're going to see more fractions coming here in
This
the
is
coming
like-
chapters. So
Chapter
get
5.
used to it.
This is like chapter 5.
Well, yeah,
Last
fine.
year.
Yeah.
You're going to see a lot more fractions coming up in the next couple chapters, so you're Well,
not
we
even
went
that
through all,
hard, but
right,
still.
right, so you
It's
have
not
to.
that bad, but like, it's just annoying.
Well, I'm telling you, it's coming, so. Yeah, again, add and subtract fractions, get common denominators, simplify as necessary, of course.
Oh, I forgot how to subtract. Oh, never mind.
Oh, no. Oh, yeah, common denominator.
Yep, whenever you're adding and subtracting, common denominator.
Come that way.
So, find the range for both.
I'm gonna go deep into my memory banks to try to remember how to do this.
Why did you say it like that?
To delve deep into my mind.
I'm just gonna gaslight myself into thinking that.
Okay, I think I have them. Alright, that was not nice, Mr. Melcher. Yeah, that's not cool. Not nice.
That was
Well,
unkind.
24 has you doing it with fractions.
What? No, it doesn't.
Yeah, it does.
Yeah.
It doesn't. What way is 24? That's not enough.
24? Yeah.
The fractions are fair game on quiz and test
No,
here.
no, they're not.
You can do what you want.
Says who? Says who?
Yeah. That's who.
Does Cookie Mr. Melcher say that?
Mm-hmm.
Didn't
Turkey, Mr. Melcher, I agree with you.
Probably.
No.
Does Mr. Melcher in front of his family, all those pictures over there, say that? He's gonna say that to his kids
Tough.
the minute they turn like 7.
Does Celine say that?
Okay, so I'll just work this out here. But first here, what I would want to do to figure out the range here is, again, the order you figure them out, whether the big, small, doesn't really matter. But to figure out my range here, I'm going to subtract these two values. Looks like I get that, so that's my bottom range there. And to figure out the high end here, I need to add them together. Here's my top end here. So I would probably just say between 2.1 inches and 10.5 inches for this one right here. Simply subtracting and adding the values.
That would be the
Whatever that third side is, it's somewhere between those two values. Certainly could be 8 inches, it could be the middle side, but we're figuring the whole range. What's the smallest it could be, the largest it could be, doesn't matter what it actually is, but whatever it is, it has to be somewhere between these two. Otherwise, like we saw, we wouldn't be able to make a triangle. We would have a side that's too long, somewhere in there. So, all right, for these here, subtract 2, 6, 3, 6. So 5 and 2, 6 minus 2. Do it this way here. Minus 2 and 3, 6. So 2, 6 minus 3, 6. Can't do that. Break one apart. Add it back in. 8, 6. 8, 6 minus 3, 6 is 5, 6. 4 minus 2 is 2. So the small end, 2 and 5 6-inches. And then the large end, add them together. 5, 6 again. 7 and 5, 6. So range would be between 2 and 5, 6 inch and 7 and 5, 6 inch for that one right there.
Are we done now?
Yeah, that's pretty much all I got. Questions?
Like and subscribe for
Like
more
and
amazing
subscribe.